7, 8, and 9 are solving ones where we have absolute values on both sides. So in theory, the absolute value of 9 could equal the absolute value of 9, but the absolute value of 9 also equals the absolute value of negative 9, right? So what they're going to do for their two cases is on the first one, they're going to leave everything the exact same. The 2u plus 6 equals the 5u plus 9. For the second case, they're going to leave one of them alone and do the opposite of the other one. So they're going to say 2u plus 6 could equal negative 5u minus 9. Notice I changed both of those signs. On Alex, they'll put a minus in front of parentheses and then distribute it out. Ends up doing the same thing. So, first case, they're both exactly the same as they originally were. The second case, I'm going to leave one of them alone and do the opposite of the other one. And then I'm going to solve them like I normally solve everything else. So on this one, I would minus my 5u to move it over, and minus my 6. 2 minus 5 would be negative 3u. 9 minus 6 is 3. Dividing, u is going to equal negative 1. On the second side, solving that, I got to move this over here, so I'm going to add my 5u and minus my 6. 2 plus 5 would give me 7u. Negative 9 plus a negative 6 is a negative 15. I'm going to get a fraction, that's okay. So my two answers, u could be negative 1 or negative 15 sevenths. And there I have my two solutions. So on number 8, same kind of thing. I've got absolute values on both sides. I want to set up my two cases that I'm going to have. First one, just leaving everything exactly the same as it is. Negative 4v minus 5 equals negative 7v plus 5. On the other one, I'm going to leave one of them alone. I usually leave the first one alone. So negative 4v minus 5. And I'm going to do the opposite of the other one. So I'm going to make that a positive 7v and a minus 5. So 7v minus 5. And then I have to solve both of my equations. So on the first one here, solving that, what should I do to solve that? Add my 7v and add the 5. 7 minus 4 would give me 3v. 5 plus 5 is 10. So when I divide, I just get 10/3, right? On the other side, in order to solve that, we would add the 5 and subtract the 7v. So negative 11v equals 0, and 0 divided by negative 11 is still 0, right? 0 can be an answer. V then could equal 10/3 or 0, and I'm going to put in those two solutions. So number 9, think about what your two cases should be, what you're going to write down on your paper to solve your problem. We have 2x minus 7 equals negative 2x plus 3. So on our first case, what should our equation say?
2x minus 7 equals 2x, negative 2x plus 3.
So we left everything exactly the same, just got rid of the absolute values. The second problem is going to be
2x minus 7 equals 2x minus 3.
exactly. So she left the left side alone, did the opposite of the right side. Most commonly on the assessments, when I see people miss the absolute value problems, it's because they forget to do two problems and they only do the one and just put in one answer. When I solve the first one here, I would
2.
Add the 2x. And
Add 7.
add the 7. So 4x would equal 10. Then I'm going to divide by 4 and simplify. So my answer would be 5 over 2. On the second one, when I solve that, what would I do?
Minus 2 and plus 6.
Minus the 2x and plus my 7, and I would get 0x equals 4. If I have 0x equals 4, what's my answer to that part of it?
4.
Nope. Nope. Remember we had those ones where we had 3 different possible answers? A no solution, all real numbers are solutions, or you put the number answer in? 0 times what number gives me 4? Nothing, because I can't take 0 times anything and get a number other than 0, right? So if I have this is a no solution answer. I can't do that, and I'm only going to put in the one answer then. So in this case, I only have one answer, just the 5 over 2. So if there's a 0 in front of your x and it's not equal to 0, it's a no solution.